Hey guys, sorry I couldn't be there today. We're going to be taking a look at more Chapter 13 stuff. Chapter 13 is, as you know, we got all the cost curves, so we're looking at that a little bit more, and we're looking at solving all the information as presented in a table. So we'll go through some notes right now, and then we'll also get to the packets as well. Make sure that you got the correct answers, and we'll make sure that you understand all the relationships between all these different lines. So we'll start off with a more simple graph. This graph appeared in one of your packets where you're looking at the fixed cost, you're looking at a variable cost, and you're looking at a total cost line. So when you look at the total cost and the variable cost line, it looks like they're getting closer together. However, you know that total cost is fixed cost plus variable cost. So when you look at these two lines, make sure that you see that they're still $100 apart when you look at them vertically. It's kind of an optical illusion, but they should be $100 apart all the way. And in the second packet that you did, you actually saw one of these graphs where the fixed cost was $300. I think it looks a little bit more clear in your graph, but don't be fooled if you see a graph like this. They are still $100 apart. So when we look at the marginal cost line, this is a very important formula to know, and hopefully you already wrote it down, but it's the change in total cost over the change in quantity. Now, when the quantity is only changing by one, it's easier. When your quantity, and this is quantity of output, changes by a different number, well, then you got to make a little bit more effort in the calculation. So, usually we have an decreasing um, at marginal cost line like this, and then it hits a point at the bottom, and then it goes back up. So it looks like a check mark. And when you're looking at that marginal cost line, why is it falling at first, and what does that mean? Well, your marginal cost declining means that your per unit cost for output is going down. And so that's good. And so when you think of this idea, think of what was going on with an assembly line example that I gave last class. You're standing at an assembly line with three different stations. And at each station, you're going to have a worker. And so that's representing your lowest point of marginal cost. Each worker is fully specialized. And so because they're fully specialized, they're just focusing on one thing. And so your per unit cost is very low. On the other hand, you will still hire more workers probably, and we don't know anything about the most profitable point, but we do know that in terms of the next unit and how much that next unit is going to cost, you'll be fully specialized at the lowest point of marginal cost. And then after that, it goes up after you hire helper workers and things like that. So the next one is average fixed cost. Very simple, fixed cost divided by quantity. We're not really going to be talking a whole lot about average fixed cost. There's not much to say. It's always falling. We're not going to graph it oftentimes. There's no relationship between average fixed cost and marginal cost. That was a question in your packet, question 10, and so we don't really have to worry about this. But just know that it's part of average total cost. And so when you have average total cost will start very high like that. And then later on, this part of average total cost will fall. Average variable cost is also part of average total cost. And so you take the variable cost and divide it by quantity. And this is also going to be part of average total cost, and it's going to be more impactful towards the end of average total cost. So in the beginning of this line on the left with 1 and 2 units, average fixed cost is the more dominant feature here. And then to the right, average variable cost will take over, and you can see that the average variable cost line is more of a U shape, unlike average fixed cost, which started really high on the left and then went all the way down. And your average total cost line is composed of average fixed and average variable. So you'll see tables like this, and then you'll see the curve that I've been talking about, where it is dominated by average fixed cost in the beginning, and then over on the right, average fixed cost is minimized, and you just have average variable cost being the dominant factor. So the various curves together. Notice these two curves, ATC and AVC. Now, in between these two curves is average fixed cost. So the negative space there is your average fixed cost. The graph line will come up in a moment, but usually we're not going to graph average fixed cost, but it's always there in between these two lines. There's your average fixed cost line that I mentioned. And then the important marginal cost line. So I'm going to have you pause the video here, and it's very important that you draw these 4 lines in your notes. Well, you don't need to draw the average fixed cost, but the 3 lines, marginal cost, average total cost, and average variable cost, we're going to be graphing that the whole quarter. So it's important that you get them right. So before you pause, draw the marginal cost line first, then draw the average total cost line, but start at the marginal cost point. So where marginal cost crosses ATC should be ATC minimum. So what you might want to do is start here, go to the right, and then come back and go to the left. That way it's easier to make sure that your marginal cost crosses ATC at ATC minimum. Extremely important. The same is true for average variable cost. So on average variable cost, you're going to be starting here where the marginal cost crosses AVC, go up to the right, and then come back, and then go to the left. And make sure that marginal cost is at AVC minimum as well. So take a moment, draw, and then we'll move on. All right, after you've completed the drawing in your notes, let's take a look at the tables. So the sub has this table. Please go up and get it and fill it out. It's important that you give this a shot. The answers will come up in a moment, but please give it a shot because on your quiz coming up next week, this is one of the quiz questions. I'm going to give you a table. It's going to have some blank spaces in it, and I'm just going to say figure out box A, figure out box B, figure out box C. So pause, go get the table, fill it out. And here are some of the answers. All right, so first, your fixed cost is $50, and you know that because total cost is 50 when quantity is 0. Then you have total cost, your line, on line 1 you have 60, average fixed cost is 50 because you just have 1 unit, and then your marginal cost goes to 20 because we're moving to the next line. So the second unit, average fixed cost 25, 1540, and then we'll just fill in the rest. So hopefully you got all these correct. And again, this is a quiz question. So different tables, different ways to figure them out. You'll have to know the formulas for each of these things. On this particular table, fixed cost was not given. Marginal cost was fairly easy to calculate in the sense that quantity was only increasing by 1. So it was just the difference in total cost. So make sure that this is something that you understand how to do. All right, so moving on, we're going to be taking a look at the relationships here. So in your packet, also, it was important about the relationships and relationships between the different lines. In this case, we're taking a look at marginal cost and average total cost. In your packet, this came up, and so when we get there, we'll go over it. But the key is that marginal cost crosses ATC at ATC minimum. Marginal cost is like your next test grade. So if marginal cost is above the average total cost, then average total cost is going to rise. Just like if your next test is higher than your average, then your average is going to rise. So we see that is the minimum point. And so when ATC when MC is below ATC, ATC is going to be falling. And so it's not what the rate of change is at this point. It's just the fact that marginal cost is below ATC, and so then that pulls ATC down. I do want to point out, though, that there is a point where marginal cost is rising and ATC is falling. And that's a very important area because that really confuses people. Right here, we have MC minimum, and then it starts rising. And right when it crosses marginal cost, ATC is falling, but at a decreasing rate. So it is possible for marginal cost to be rising and ATC to be falling. The key, though, is that marginal cost is below ATC, so ATC is still going down. Then, a little bit easier to see, when we have marginal cost above ATC, ATC is going to be rising. And that's just like the next test grade, pulling your overall average up. And so there's your minimum point. Marginal cost crosses ATC at ATC minimum. Now, initially, as I was saying before, average fixed cost is dominating and it's pulling ATC down. And then a VC takes over and it pulls a TC back up. Now, that minimum point right there, that's right where marginal cost crosses ATC. It's got a word. You got to know this word. It's called productively efficient or at the efficient scale. So that is ATC minimum, productively efficient. Make sure you get it down. All right, so at this point, we're going to be moving on to other things. In class, we would go and correct your packets at this point, but I'm going to be continuing here, and then we'll go back to the packets in another video. All right, this is the last topic in Chapter 13. So this is kind of separate from what you were just doing. This is the last topic. So I need you to draw a graph in your notes, and I need you to draw 3 factory sizes on that graph. So this is a long run average total cost curve that we're going to be creating. And to create that, first thing we do is create 3 smaller cost curves. So these are 3 ATC curves. And each ATC represents a factory size. So you're a business owner. You've got to decide what factory to go in. Where are you going to get the most efficient production? In the small factory, the medium factory, the large factory. In the short run, you're stuck. So once you pick a factory, you got to produce in that factory. But in the long run, you can change different factories. So let's say you're going to be producing a quantity, and basically it's your quantity that's going to determine what factory size you're going to go into. So if you were going to do anywhere from 0 to quantity A, you're going to pick the small factory. And you're going to do that very simply because it's going to give you the lowest total cost. Your ATC, the medium factory, it's an option, but it's got a higher ATC. So you don't want to do that. So you're going to stick with ATCS, the smallest factory, on any quantity between 0 and QA. Then you decide that your business is doing better and you're going to move to a larger factory. So between QA and QB, you're going to be going into the medium size factory. And then if your company is doing very well and you produce a lot of quantity, you're going to move factories, and so you're going to move into the largest factory. So your long run ATC curve, and I'm going to have you do this on the packet that the sub has, your long run ATC curve is really the bottoms of all of the ATC curves that you have. So you see a graph like this. It goes down and then up a little bit and then goes down. But the idea is that you're creating a long run ATC curve. And if we just want to smooth that out a little bit, we can imagine instead of just 3 factories, we're going to be having many factories. And so eventually your long run ATC curve is usually presented like this, with the smooth bottom rather than the ups and downs at the bottom of each curve. So you've got a bowl shape here. So your long run ATC curve is generally depicted as a bowl shape. 3 vocab words you need to know. First one is economies of scale. So all ATC curves have this area. even the short run ATC curves, and it represents that ATC is falling as your quantity is going up. So what this means is that this is the benefits of mass production. As you're producing more, your average total cost is falling. And you guys already know that. We know mass production is beneficial. So this means that you might be putting in 10% more inputs, but maybe getting 15% more output. So this is your economies of scale. As you ramp up production, you're able to get more and more out at a lower and lower cost. So that's a good spot for your company to be in. It means that your company is growing. This is also a good spot for your company to be in. So this is constant returns to scale. Your quantity is increasing, ATC is staying the same, but your business is growing. You're increasing your market share. More products are being made. More workers are being hired. Your company is growing. You have more employees. And if you remember the smaller ATC curves, you may even be moving locations, changing factories, things like that. So all of this is good. You're putting in 10% and you're getting 10% more output at every point along this line. Then we get to the last part of the curve. So the last part of the curve is the diseconomies of scale. ATC is rising as your quantity is increasing. Not the best place to be. You might still be profitable, but what this is saying is that you're putting in 10% more and you're only getting 5% more output. So things could be better. Maybe communication is breaking down. So your company is growing larger. You go from 5 employees to 45 employees. And before you were able to talk to everybody and just see them, and so communication was more informal. And then as you grew, how are you going to communicate? Are you going to go over a Slack channel? Are you going to do email? You've got to figure out how you're going to get that company together. And so maybe as a result of that, things are moving a little bit more slowly. So this is in the area of diseconomies of scale. The one thing I do want to point out is that all of these areas also exist on a short run ATC curve. So the College Board, they might try and trick you, and they know that you've learned these terms on a long run ATC, but they'll ask you where they appear on a short run ATC curve. And they all still exist. The constant returns to scale point on a short run ATC is ATC minimum. So it is productively efficient. It is a constant returns to scale. So that's just kind of a trick question. The vocab terms do apply to both short run and long run ATC curves. So that's it for Chapter 13 notes. Take a look at the next video for answers to the key, for the 2 packets, and then there's some work in class for you to complete. Thank you.